Hello, Dr. Te. Today I'm presenting my group submission for the first milestone of data mining assignment. I am Ammar Alyousfi with metric number WQD 170064. In this milestone of the assignment, we are required to build a web crawler that acquires data about KLSE stock market. So to get this data, we use two sources of data. The first is the star website. The second source is malaysiastock.biz website. Here is the first source, the star, and the second one. Each one lists the prices for all KLSE companies. First, for the star website, we started crawling the data from the star website on 24 February. We started crawling 3 times a day. Then we increased the rate on 3 March to become 6 times a day, at 1 a.m., 5 a.m., 9 a.m., 1 p.m., 5 p.m., and 9 p.m. in UTC time. So we crawled data from star website many times a day. And we crawled data for all companies listed on the star website, which are 1,854 companies. Crawling the data for all companies take 42 minutes on average. And now for malaysiastock.biz website, we started crawling data on 3 March, 6 times a day, 12 a.m., 4 a.m., 8 a.m., 12 p.m., 4 p.m., and 8 p.m. in UTC time also. The same for malaysiastock.biz. We crawled data for all companies listed on malaysiastock.biz website, which are 1,869 companies. And crawling the data for all these companies took on average 43 minutes. Now, how the crawling was done? We scheduled the crawling scripts to run on a server. We rented a server on Amazon Web Services EC2, Elastic Compute Cloud. So we rented this server and we scheduled our crawling scripts to run many times a day. To schedule the scripts, we used a Linux utility named crontab. So we used this utility to schedule our scripts to run many times each day. This is our server on Amazon Web Services EC2. And to access our server, we used Secure Shell SSH to access our server remotely from our local machines. And this is a screenshot of our cron tab file that we used to schedule our scripts to run many times a day. To write our scripts, our crawling scripts, we used Python with many of Python libraries like requests, beautiful soup, urllib, and others. And the output of these scripts, we wrote our crawled data on into text files. We followed a specific format. Uh, a sample of the output file can be seen on the right of the screen. First, we write the company name, the open price, the high price, the low price, and the last price. Then we write the update time of this price. This data can be later migrated to a database or other forms of storage using simple scripts. Now we start a demonstration of what we did. First, here is the code that we used to crawl data from the STAR website. First, we import the libraries that we need. Then, these two lines are used to change the working directory to the directory of the script. This will help us later. So for example, later when we specify a file name, we don't need to specify the full path or anything. We just put the files with the script in the same directory and use these two lines. And this is our base URL. We will see how to use it later. Then we need the company names to crawl the data. So we already crawled the company names from the STAR website using JavaScript code. Here is the resulting file. It contains the names of all companies on the website. So here we read this file and store the company names in this list, company names. Then we create empty lists to hold the data, the open prices, high prices, low prices, last prices, and update times for all companies. After that, we create an error log file for it. So if during the crawling an error happened, then instead of stopping the script, we just write the company name with the time of the error to this file. Then we start the crawling. So for seeing company names, for each company in our company names list, which contains the names of all companies on the website. So for each company, we create the URL for this company. The URL will be the base URL, this one, but we replace these brackets with the company name. So if the first company name is 3A, then its URL becomes like this. We do this with the format function, and we use the library URL-lib to make the company name suitable for URL. For example, there is a company named D&D. We can't put this in the URL because the URL cannot contain this character. So it needs to be encoded to become like this. So we use this function to encode the company name. Then we print a message to the user so he knows that we are scraping the URL of this company now. Then we do the following. First, we use the requests library to download the web page of the company using the URL we created now. and we use also headers. This this is the headers we use. This header specifies the user agent to use. That's because some websites prevent web crawlers from accessing the website. They block the web crawlers. So to avoid this, we use this user agent, this header with the user agent, to prevent such problems. So we download the web page of the company and we get its text, the text of the response, which is the HTML code of the company page. Then we parse this HTML code using Beautiful Soup library, which will give us the soup variable. It contains the HTML document parsed by the Beautiful Soup library. And now we extract the elements that we need for the company. For example, we start with open price. We use the function select one from the Beautiful Soup library. Here we specify the CSS selector to select the element that we want, which in this case the element that specifies the open price, and we get the text of this element, which is the open price. So for example, this is the star website. If we open a company, then this is the open price. We can see this element has this ID. So we use this ID to access the element, the open price element, and we get its text, which is the open price itself. We repeat the same process for high price, low price, and last price, and also for update date and update time. We get all this data. The update date can be shown here, update date and time, and here the open price, high price, low price, last price. We scrape all of this data. So we do all of this inside a try clause. So if any error happens, we go to the accept clause and write the company name with the time of the error. Then after that, now the open price variable contains the open price for this company. High price contains the high price of this company, and so on. Now we append these values, we add them to the lists we defined earlier here, before the loop. These lists will contain the values for all companies. So for this company, we add the values to the lists, and we repeat this process for all companies. This is achieved by foreseeing company names loop. After that, we now have these lists full with data about all companies. So now we need to write this data to the output file, which is a text file. The name of the file will be like this. It starts with the prices, then the date and time of the crawling. To put the current date and time, we use the time Python package and the strftime function to put the day, the month, the year, the hours, and the minutes in the file name. Then we write the output, the contents of the lists, to the text file. So we use this. Here we use the Python zip function, which do the following. For example, if our company names list contain these names, of course it will, in the real case, it will contain 1800 value. But now, just for example, if this contains these four values, and company open prices list contain these values, and high prices list contain these values, and so on, then if we use the zip function with these lists, it will do something like that. It will gives us, uh, for for example, the first list it gives us contains data about the first company. So zip function takes the first item from the first list, the first item of the second list, the first item of the third list, and so on, and put them into a list. So when we say, uh, in our scraper, like this, for C, OBB, HIB, LOB, LAB, and U in zip these lists. So in the first iteration of this loop, C will be the name of the first company, OBB the open price of the first company, HIB the high price of the first company, and so on. So we write the data of the first company to the text file, then the second company, and so on. Okay. And for Malaysia stock.biz website, we used this script. It is similar to the star website script, but we followed another approach. Here in Malaysia stock.biz website, okay, so Malaysia stock.biz website provides a list of companies for each alphabet. For example, for the letter A, this page contains all companies whose names start with the letter A. So what we did was, we download each of these pages, and for each page we get the links of all companies listed. For example, here in the A page, the page of letter A, we get the links of all these companies, because we get the link from here, we get this link. Then for each company we download its page and get the data that we want: last price, open price, high price, and so on. So here is the code. We loop over all alphabets A, B, C, D until the end. Then we create the URL for this letter, which is the base URL, this one, but we insert the letter instead of these brackets. So in the first time it will be C will be A, the second time B, the second time C, the third time C, and so on. And similar to the star website, we download the page, in this case this page, and we parse the HTML code using Beautiful Soup library, and then we get all links using select function of Beautiful Soup. This CSS selector will get us all the links in the page, all these links. So for each of these links we build the URL of the company. Each link is a link to a company page. So we build the URL of the company, Then we print a message to the user saying that we are scraping this URL now. Then we get the company name from the link element, and we download now the page of the company using requests.get. Then we parse the code of this page using beautiful soup, and now for this company we get the last price, open price, and because Malaysia stock.biz does not list the high price and low price, instead it lists this. For example, for this company it lists the day range, where this is the low price and this is the high price. So what we do is we extract price range from the page, and then we split it to get the low price and high price. Then we get the update date, which is here, market date. Then, as with the star website, we append the values of this company to the list, to the lists that that will contain the values for all companies. So for each alphabet we download the page, then we get the links of all companies in the page. Then for each link we download the company page and extract the data that we want, then update the lists. At the end, our lists, these lists, will contain the values for all companies. Then we write the data that we crawled to a text file also. The name is Malaysia stock prices, and the name also contains the date and time of the crawling. And we write the results to the text file as before. So the output file is similar to this file. Each line contains the data about one company. For example, the first line about the company name, the company named 3A. This is the open price, then the high price, then the low price, then the last price, then the update date time, the date and time the website updated the data. We notice here the name of the file as we specified. This is a file for the star website. So as we saw in the code, the name is prices, then the date and time of crawling. We said earlier that we are now crawling each website 6 times a day. This means that each day we will have 6 files like this for each website. So this is the code and the output. Now let's see how we schedule the scripts on the server. Here is the Amazon Web Services. We have a server on EC2 platform. Here is our server. It's running always on. So to access the server, we use the terminal. The command, we use the secure shell as we said in the slides, and we connect to the server. Now we are inside the server. Now we will see the cron tab file, which we used to schedule the scripts. So cron tab, and here at the end we see this line for the star crawler, the crawler of the star website. We run it at these times, and the same for Malaysia stock.biz website. So this is the cron tab file. It will run the scripts. We uploaded the scripts to the server. So this cron tab runs the scripts at the specified times each day. So when the script runs, it writes the output file on the server, and then we can download these files from the server. We can see these files using FileZilla application. We connect to the server, then we navigate to our folder. Here we can see the output files for the star website. For example, today, 6 March, 3 files have been written already, and 3 are coming. These 6 files for 5 March, and so on. Also, inside this folder, we see the output files for the Malaysia stock.biz website. As we said earlier, we are crawling each website 6 times a day. Also, for an extra work, we scrape data for cryptocurrencies from this website. This website contains data about cryptocurrencies, for example, Bitcoin, XRP, Litecoin, and so on. So we used a Python script also to crawl the data for each. We read a file containing the names of the cryptocurrencies. Then for each cryptocurrency, we download the page and we parse the HTML code, and we extract the elements that we want: the price, the crypto name, and its symbol. Then we process this data that we got, we clean it, then we write the results to a text file for each company, for each cryptocurrency. Like that, we read the cryptocurrencies from crypto list file. Then for each company in the file, for each cryptocurrency in the file, we create a worker instance here with the code is the cryptocurrency code, and we execute the worker, which means the crawling itself. So an output sample of this script is like this. Here we see the crypto name, then the crypto code, then the price in US dollars, and the timestamp. Thank you, Dr. Tay, for taking time to watch this video.